So, so here are our azole antifungals and their structure-activity relationships. So before we move on to the structure-activity relationships, let us first describe the main structure of our azole antifungals. Our azole antifungals are primarily made out of triazoles. So when we say triazoles, this refers to any heterocyclic compound with a molecular formula of C2H3N3 having a 5-membered ring of 2 carbon atoms and 3 nitrogen atoms. Triazoles are also aromatic in nature. So you can see the structure of triazole on the right side of the screen. And let us break down the description. It is a heterocyclic compound. So it means it is made out of different atoms. So in this case, C, H, and N. So it qualifies as a heterocyclic compound. Next, it is made out of 5 members. So you can see it's a pentagon-shaped structure. So we have 1, 2, 3, 4, 5. There are 2 carbon atoms and there are 3 nitrogen atoms. And finally, triazoles are also aromatic in nature. So as you can see, there are double bonds in the structure. And if you actually compute for the aromaticity, it qualifies as a aromatic compound. So let's move on to our structure-activity relationships. There are only 3. So the most potent antifungal azoles possess 2 or 3 aromatic rings, one of which is halogen substituted. The halogen atom that yields the most potent compounds is fluorine, although similar functional groups such as sulfonic acids have been shown to do the same. And finally, the nonpolar functionality confers high lipophilicity to the antifungal azole. So let's take a look at some structures and let's have some examples as well. So first, our first SAR is the most potent antifungal azoles possesses 2 or 3 aromatic rings. 2 or 3 aromatic rings with at least one of which is halogen substituted. So let's have fluconazole, 1 aromatic ring, 2 aromatic ring, 3 aromatic ring, and one of them is halogen substituted. Take for example this ring, it is substituted with fluorine twice. Let's have clotrimazole. It has 4 aromatic rings, and one of the aromatic rings is substituted with a halogen, this time chlorine. And finally, you have your voriconazole. You have 3 aromatic rings, and 2 rings are substituted with our fluorine. Next, SAR is the halogen atom that yields the most potent compounds is fluorine, although functional groups such as sulfonic acids have been shown to do the same. So we have the same group of drugs on the screen, and as you can see, fluorine is present in 2 out of 3 structures. This is because fluorine gives the most potent compounds, except for clotrimazole, which has a halogen of chlorine. Now, sulfonic acids have been shown to do the same, but it is rare to see sulfonic acid on our antifungal azole. So our sulfonic acid has this structure right here. RS double bond O R. And that is our SARs for our azole antifungals.